In this video, we're going to go over inequalities in triangles. So we're going to start off with some theorems that we need to know. And so we're going to start off with our first one, which is going to be the comparison property of inequality theorem. So we have if A is equal to B plus C, and we know that C is greater than 0, then A must be greater than B. So recall that the exterior angles of a triangle is going to be equal to the sum of the remote interior angles. Okay, so that's giving us that the measure of angle 4 is going to be equal to the measure of angle 1 plus the measure of angle 2. Then we have our corollary of that, so just kind of building off of it. We've got that the measure of angle 4 is going to be greater than the measure of angle 1, and it's going to be greater than the measure of angle 2 because those two are being added to get the measure of angle 4. So separately, measure of angle 4 should be still greater than both of them. All right, so we're going to, in this first problem, explain why the measure of angle 4 is going to be greater than the measure of angle 5. All right, so looking here, we've got that the measure of angle 5 here that we see is going to be congruent to the measure of angle 2. So the reason why those are congruent is because they are corresponding angles. And so we can say that the measure of angle 5 is going to be equal to the measure of angle 2 because of corresponding angles. So that's what I'm going to start off with. Okay, and that's going to help me because then we've got to talk about that measure of angle 4. Well, the measure of angle 4 here is going to be this angle outside of my smaller triangle that we see of DEC. And so the measure of angle 4 is just going to be equal to me adding the two remote interior angles of angle 2 plus the measure of angle 3. So that's where I'm going to go with this next over here, is just going to kind of write out that my measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3. And so, well, if we look here using what we just mentioned, the fact that measure of angle 2 is equal to measure of angle 5, we can use substitution . And we would get that the measure of angle 4 is equal to the measure of angle 5 plus the measure of angle 3. And so therefore, using our corollary of the triangle exterior angle theorem, the measure of angle 4 is going to be greater than the measure of angle 5. Okay, so now moving on, we've got some other theorems here. And so they are going to state that in a triangle, the larger angle is going to lie opposite the larger side. And in a triangle, the longer side is going to lie opposite of the larger angle. Okay, so let's look at some problems below that to see what we can kind of figure out. So in triangle RGY, we know that RG is 14, we know that GY is 12, and RY is 20. We want to list the angles from largest to smallest. So something I do want to kind of mention in this unit, it can be kind of tricky because they do switch it up on you. And so you want to make sure that you are highlighting, underlining that largest, smallest, however the order is that they want it in, because that can really mess you up. Okay, so looking at it, you could draw a picture if you wanted to, but I could also look at the fact that I want the largest. And so I see the largest side is going to be that RY is 20. And so opposite of that would be the letter that I'm not seeing. And so when I look at RY, I'm going to see that G is missing. So G is going to be opposite. So I'm going to start with angle G. Then my medium is going to be that 14. So RG, opposite of that would be my angle Y. It's the letter that I'm missing. And then lastly, for my smallest side, we have that GY, which I'm missing the letter R. And so angle R is going to be the smallest angle. Now, you could kind of draw out your own picture if you needed to see all of this, or you can kind of just compare from that. So let's look at number 3. And so for number 3, they did give us a picture here to go based off. So in this one, we can talk about how we could use that picture. But we're listing the sides in order from the shortest to the longest. All right, so real quick, I'm going to just start off by finding this missing angle here, this angle T. So to do that, I'm going to add that 62 and that 58 degrees. And I'm going to get 120. And then when I subtract that from 180, the sum of my interior angles, I'll be left with a 60-degree angle here. So I can use my shortest one, the smallest angle, is going to be this angle here, that 58 degrees. And so opposite of that would be the side we don't touch. And that would be that side TS. Then we would have that 60 degrees. So opposite of my 60 would be that US. And then lastly, we have that 62 degrees. So opposite of my 62 degrees would be that side TU for my longest. All right, now let's move into some other problems. So in this figure, it's not drawn to scale. We want to just kind of mention that. We don't always draw everything to scale in geometry, so just keep that in mind. And so part A is asking us to name the angle with the least measure in triangle LMN. So I'm going to look here at my triangle LMN. So when they're saying the least, we want to be dealing with the smallest. And so looking at what we have here, we see that the smallest side is that 6. So that's going to be opposite of that angle N. So angle N is going to be my answer. Then in part B, they ask which angle in triangle MOT has the greatest measure. So we're going to focus on MOT, this bottom triangle here. and we're looking for the greatest. And so I'm going to look at that 9, and opposite of my 9 is that angle T. So my greatest angle is going to be angle T in that triangle. And then in the last one, they are asking us to name the greatest of all 6 angles in the 2 triangles. So what we need to do is we need to compare. The one thing I want to mention is just because it's the largest side does not mean it's the largest angle in all of them. It just means in that specific triangle, it'll be the largest. So here, what we can do is, I'm going to switch to black for this. And so I see that my largest side is LN. So that's going to be my 10. And so this angle here is currently my largest one, which we know is congruent down here because of our lovely vertical angles. And so this allows me to kind of tie the 2 triangles together. But what I notice is when I look opposite of it, it's actually the medium angle. It's not the largest, it's not the smallest, but we can get bigger. Okay, so that means that in of all triangles, I then need to identify that my largest angle will be angle T. Okay, so like I said, be very careful. It's not just the largest side in both triangles. That whole it being the largest angle only applies for that specific triangle. So when we're bouncing between 2, we need to be able to kind of compare. And so my vertical angles allows me to do that. So let's look at our next one, which will kind of use a little bit of that as well. So we are asked for the longest segment in triangle CED. So I'm going to start off by highlighting CED. That's going to be this triangle here. And just to make sure we are dealing with the largest one, I'm going to find this angle here. I'm going to take that 50 plus 45 to get that 95. And I'm going to subtract that from 180. And I'm going to be left with 85 degrees. Okay, so that means that my largest angle is going to be this angle D, which is going to be opposite of my side CE. So my largest segment in that triangle is going to be CE. Then in part B, we asked, what's the longest segment in triangle BCE? So BCE here is going to be this green triangle that I'm highlighting. And once again, just to make sure I am using the correct angle, I'm going to find my missing angle here. So I'm going to add 40 plus 75, which will give me 115. And then I'm going to subtract that from 180. And I will be left with 65 degrees. All right, so that means that my largest angle is going to be this angle here. And so my largest side is going to be that side BE. All right, so moving into question C, we have, what is the longest segment in the entire figure? All right, so kind of like in the previous one, we want to find something that they have in common that will allow us to kind of jump back and forth between the 2 in comparisons. And so for me, what I'm going to see here is that lovely reflexive property here that will allow me to kind of compare. So remember, when we looked, okay, my longest segment in that triangle CED was CE. But if I look across from it, I will notice that that is now a 40-degree angle, which happens to be the smallest angle in that triangle BEC, which just means that our sides get larger in that triangle. And so my longest side is going to be that segment BE again. All right, now in the last one, we have our shortest segment in this figure. Okay, so we've already kind of addressed this, but let's just look at it. We've got that my 40 degrees here is going to be a small angle in this triangle BEC, and it is opposite of that segment CE, which if I look in the other triangle, I notice that it is actually the largest segment in that one, which means when we deal with that 45 degrees, the smallest angle in this triangle, the side opposite, CD, should be the shortest segment in this entire triangle. All right, now let's look at the back side. All right, so on the back side, we're going to go ahead and talk about the triangle inequality theorem. And so this theorem states that the sum of the lengths of any two sides of a triangle is going to be greater than the length of the third side. Okay, so let's look at some practice problems for this. So we have for number 6, a triangle has side lengths 7 and 12. What are the possible lengths for the third side? So we're going to set up some scenarios. And so in order to do this, I'm going to go ahead and, since I don't have the third side, I'm going to call it S. So I'm going to say let S equal the third side. All right, so we have 3 scenarios. So we've got the scenario where we'll add the 7 plus S, and it should be greater than 12. We can have the scenario where we'll say 7 plus 12 is greater than S. And then we also have the third scenario where we would have that 12 plus S is greater than 7. Okay, and so what I'm going to do is I'm going to solve each one of these. So here I'm going to get that S is going to be greater than, I'm going to subtract that 7 from both sides, and I'm going to get 5. Then over here I'm going to add these two, and so I'm going to get 19 is greater than my S. So S should be less than 19. And then in my third scenario, I'm going to get that S is greater than, and when we subtract, we're going to get -5. So with this scenario, scenario C, what I'm going to notice is that we should not have negative lengths. So not possible to have negative lengths. And so I already know that this right here will not work. Okay, because this is saying that yes, it is greater than -5, but it's saying in this scenario you could have -4, -3, -2, -1, and none of those lengths actually will work in our triangle. So we're going to focus on these two scenarios over here to write our inequality. And so we are saying in this first scenario that my S is going to be greater than 5. But in scenario B, we're saying it's going to be less than 19. So then my answer here is just going to say that S can be greater than 5, but less than 19. Now, that's not too bad. We're going to look now at our last problem. And we're going to do the same idea, but with our expressions. Okay, we do know one side, but we know that two of the sides are going to be expressions. We're going to find the possibilities for my x. Okay, so we're going to do the same thing. And so I'm going to start off with my scenario A of just adding them. We've got 3x plus 20 plus that 75 we'll say is going to be greater than 2x minus 10. Then I can have my scenario B where I'm going to say 75 plus that 2x minus 10 is greater than 3x plus 20. And then lastly, we'll have scenario C where we can say that 3x plus 20 plus my 2x minus 10 is going to be greater than that 75. Okay, so those are my 3 scenarios, and now I'm going to just run through and solve them. So let's go back over here to scenario A. And I'm going to combine my like terms to get 3x plus 95 is greater than my 2x minus 10. So I'm going to subtract that 2x to get x, and I'm going to subtract my 95, and I'm going to get negative 105. So here my x is going to be greater than negative 105, which once again, it's not possible. No negative lengths. Okay, and then let's look at scenario B. So we're going to combine our like terms. We're going to get that 2x plus 65 is greater than my 3x plus 20. And then I'm going to subtract my 2x from both sides and then subtract 20 from both sides. So here, when I subtract the 20, I'm going to get 45 is greater than, and when I subtract my 2x, I'll be left with my x. So x is going to be less than that 45. And then in my last scenario, combining my like terms here, I'm going to get 5x plus 10 is greater than 75. So 5x is greater than, I'm going to subtract that 10 to get 65. So x is greater than 13. All right, so remember scenario A did not work, but with scenario B and C here, we got that my x is going to be greater than 13. Okay, so we're going to start off with my 13. We got x is greater than 13, but it's going to be less than that 45. Okay, so then this right here would be my final answer for question 7.